Cubes and cube roots. In this video, we will look into the patterns of cubes. For cubes, the first pattern is cube numbers can be expressed as sum of odd numbers. We can take any perfect cube. We will try to observe this from the starting onwards. That is 1 cube is 1. It is just 1. It's an odd number. Next is 2 cube, 8. 8 can be written as 3 plus 5. 3 and 5 are odd numbers. Now here we have to observe that 2 cube involves sum of 2 odd numbers. Next is 3 cube. It can be written as 7 plus 9 plus 11. Here again 3 cube requires 3 odd numbers in the sum. 4 cube involves 4 odd numbers in the sum. And then 5 cube can be written as sum of 5 odd numbers. Here we have written in a sequence, so we are able to identify the odd numbers involved easily. Now if we take any perfect cube and then we want to write it as sum, writing like this in sequence will take a lot of time. So there is a process to identify the numbers involved. The only thing we have to observe here is when we are writing cube of any number as sum, say 5 cube, this involves 5 consecutive odd numbers. Now we'll see the process on how to identify those numbers. Consider this perfect cube, 1331. First step is to write it as a cube of a natural number. This number can be written as 11 cube. Now this 11 is base and 3 is power or exponent. The second step is to divide the original number with this base. On dividing that, we will get a quotient. Take that quotient. Here it is 121. And this 121 forms one of the required numbers. We know that 11 cube needs 11 odd numbers to form the sum. And this is one of them, means 10 more numbers we have to identify. 10 divided by 2 is 5. So take 5 on right side and 5 on left side, continuous odd numbers. Here 121 towards left and right we are identifying the odd numbers. Those have to be in consecutive order. After identifying these numbers, just to add these numbers and that will give the required perfect cube. Now this is for odd cube number. What is the process for even cube number? Now consider another number. Here 5832 is an even number and it is a perfect cube. Now we already know the steps. First thing is to write it as a cube. So this is 18 cube. 18 cube is 5832. After this, the second step is to divide the original number with the base. Means we have to divide with 18. That gives 324. Now 324 is not an odd number, but how to identify the numbers here? 18 cube requires 18 odd numbers. 18 divided by 2 is 9. So we'll take this 324 and write the consecutive odd numbers on left and right of this number. And on both sides, we have to consider 9 numbers. So we take on both sides and this is the required list. If we add all these numbers, it gives 5832. So now we have seen how to write any perfect cube as sum of odd numbers. The second pattern we have in cubes is each prime factor appears 3 times in the prime factorization of any cube number. Consider a cube number. We'll take this particular perfect cube. Now do the prime factorization of this. And this is the way we follow that. Now the number can be written as product of all these prime numbers. Here if we observe, 2 has appeared 6 times and then it is 7. So we'll write it as the product. Now in this, if we do grouping, the first initial 3 2's can be grouped. And then again we have 3 2's and then 7 appeared 3 times. If we observe here, every prime number, it may repeat, but any prime number, it will appear 3 times. This can also be written as 2 cube into 2 cube into 7 cube. Cube means that particular number has to be multiplied by itself 3 times. So every prime factor appeared 3 times. Now, way to use this concept. Take this particular scenario. It is like to find the smallest number by which 392 must be multiplied so as to make the product as a perfect cube. First thing is to see whether the given number is perfect cube or not. Take this 392 and do the prime factorization of that. Now if we observe here, 2 appeared 3 times and 7 appeared 2 times. We'll write the number as product of these prime factors. Only 3 times 2 is available. 7 is there for only 2 times. For a perfect cube, as per the pattern we have seen, every prime number has to present 3 times. Now if you include one more 7, then we will have 3 7s. So for that we have to multiply this with 7. To maintain the balance of equation, we will multiply on either side of this equation. Then this is how it would be. Now if we see the right hand side, 2 appeared 3 times, even 7 appeared 3 times. So this can be written as 2 cube into 7 cube. As per the law of exponents, a power m into b power m can be written as ab power m. So here 2 power 3 into 7 power 3. A is 2 and b is 7. 3 is m. So substitute the values, then it will become 2 into 7 whole power 3. 2 into 7 is 14 power 3. So this 392 is not equal to 14 power 3. We have multiplied that value with 7. So what is the new number? The new number is 2744. So this particular number 2744 is a perfect cube and it is cube of 14. So we have to multiply 392 with 7 to make it as a perfect cube. In this video, we have seen different patterns of cube. The first one is cube numbers can be expressed as sum of odd numbers. We have also seen the process of how to identify the odd numbers. And the second thing we have seen is each prime factor appears 3 times in the prime factorization of any cube number and way to use this particular pattern.